Okay, so let's take an example where Bob can send Alice knowledge of his password, and Alice won't be able to determine Bob's password, but will be able to send a challenge to Bob about his password, and only Bob will be able to solve the puzzle. And we'll do this by matching Bob's password onto an elliptic curve point. So in this case, what we do is we take a hash of Bob's password, and then we find the nearest point on the elliptic curve in which we can map onto the elliptic curve. So we have a point px, py, which is the nearest point. Typically what we do is we keep adding 1 to this value that we get until we find a point on the elliptic curve, and that becomes an elliptic curve point. Then that is then registered with Alice, and it might just be the x value, and she will store that as Bob's password, but she won't be able to determine what the password is because it's too difficult to determine the point on the elliptic curve as it maps to the password. Now when Bob wants to log in, Alice sends a random value. Bob will then take the point that he has, and we'll call that P, and calculates P R times P, which will be another point on the elliptic curve where it's P added R times. Feeds that back here, and Alice will check that, multiplying it by the inverse of R, and we do this through a modular inverse of the order, and that will cancel out, and we'll end up with the original point on the elliptic curve. So in this way, Bob can hide his password from Alice, and we can match it onto the elliptic curve. Then we can work out points through the challenge, and then Alice will perform an inverse mod of n, where n is the order defined for the elliptic curve. Okay.